Hi everyone. Today we will be discussing the topic called semiconductor. So let's start. So in semiconductor, suppose I'm taking a material. This can be any material. Okay. This is a kind of experiment. We are taking a material and we are applying a charge across it. We are applying a voltage across it. Okay. So the case one is like we apply the voltage and there will be a current flow. You can see from the green color line. So the current will be flowing from the positive and it will be going and it will be completing the loop. There is a current flow. So when a voltage is applied and if the current is flowing in a good way, in a good amount, then we called it as a conductor. Okay, then we will go to case 2. Case 2 is like we apply the voltage but nothing is happening, no current flow. That is, these green lines won't be there. Then it is called an insulator. And there is one case 3. There is a third case. We apply the voltage, some current is flowing, like a moderate amount of current is flowing, not like the first case, but comparatively very less than that, but a current is flowing. Such materials are called semiconductors. So the conductivity says how easily the material allows the current to flow through it, or you can say the amount of current flows or the material allows to flow through it will define the conductivity, and it is expressed in Siemens per meter, and it is different for different materials. And examples of these insulators are wood, glass and Teflon. And the semiconductors, the examples are silicon, germanium, gallium arsenide, etc. And these three are the main materials which are mainly used in semiconductor industries. So we told like silicon, germanium and gallium arsenide. So these materials, they are, silicon means it's silicon only, nothing is added to it. It is containing only silicon atoms. Such type of semiconductors are called intrinsic semiconductor. So while adding impurities, like I'm adding some impurity into this pure form of silicon, then this conductivity can be changed. Okay, and this property is useful in designing various electronic devices. And this is the basics of semiconductor devices, and this is the main point, and this is the reason why we have mobiles, TVs, laptops, etc., which we are using. All this starts from this basics only. Okay, now see the silicon atom, its atomic number is 14. So the first shell will be having 2 electrons and the next shell will be having 8 electrons, and the remaining 4 electrons will be in the last shell, and these are called the valence electrons. I think you all know about it. So suppose the silicon atom, and this is the last shell, last 4 valence electrons are there in the silicon atom, and it will be bonded with another silicon atom via covalent bonds. See, this is bonded with this via covalent bond. That means they will be sharing the electrons. Okay, because the last orbit, this should also complete 8 electron, no? So what happens is like this electron and the sharing this electron will make 2 electrons here. Likewise this electron and sharing this electron will make it 2 here. So 2, 4, likewise here also. So 2, 4, 6, 8, and that orbit will be totally filled. So this is how it happens. So this is a case of an intrinsic semiconductor. This is an intrinsic semiconductor. Now what happens? I told I will be adding impurity. So what type of impurity I will be adding? Silicon is in the 14th group. You all know. So I can add impurities either from, impurity means I am adding something which is not silicon. That is what I meant by the impurity. If I am adding anything other than, suppose I am removing this and adding any other atom here, anywhere here, it can be anywhere here, then it is an impurity. I am removing this and adding something. I am removing this and adding something. So that is what I call an impurity. So silicon is in the 14th group. Okay, and I can add impurity either from the 13th group or the 15th group. Okay, if I add impurity from the 13th group, I hope you all know boron, aluminum, gallium, indium, thallium, that consists of the 13th group. So suppose I am replacing the silicon and I am adding an aluminum here. Okay, and you all know 13th group, the valence electrons will be like 2, 8 and 3. There is only 3 electrons here. See, I have replaced the silicon and I added aluminum from the 13th group. Okay, so this aluminum is having only 3 electrons here, so there is a lack of 1 electron here, that makes a hole. So aluminum has only 3 valence electrons, so if we add it, 1 hole is formed. See, I replaced the silicon, I added 1 aluminum, so here 1 hole is formed. Okay, so what happens is like, no, generally what happens is like, in normal conditions, due to the heat, you can say, there will be an electron. Suppose this particular electron, it will just getting some energy from the heat or temperature. As temperature increases, it will get some energy and it will get released from this, and it will be moving around somewhere here, and here it will become a hole. Since no electron, hole means no electron is there, electron was there and it went to here, it went here, so it becomes a hole and the electron is here. So likewise, other places also it may happen. Suppose here this electron also moves from here to here, and here it becomes a hole, and here this electron will be, okay, somewhere around here, okay, this electron will be. And what happens is like, the electron which has been the electron which was there and which traveled from here to here, and by creating a hole here, it is here, it is, suppose it is here, now a hole is here. So what happens, it will sit on this hole. Okay, this will, and the electron which was earlier here, who is now here, it will sit on some other hole created by some other electron. Likewise, this movement of both electrons and holes will happen in this semiconductor, this intrinsic semiconductor, and that is how the conductivity occurs, due to the movement of both electrons as well as holes. So now what happens here? Instead of silicon, we have put aluminum. We remove the silicon and we put aluminum. Aluminum has only 3 electrons in the valence shell. So one hole, there is a lack of electron here, that's a hole is here. So we replaced 1 aluminum and we got 1 hole. And if we replace more aluminum, we will be getting more holes. So more aluminum impurity means more holes will be formed. So this is a p-type. So this is a p-type. So these holes will be the main reason for the electrical conductivity of the p-type semiconductors, you can say. And see, we are taking the case of n-type semiconductor. Instead of silicon, we replace silicon with an element from the 15th group. I think you know what 15th group is, right? Okay, nitrogen, phosphorus, arsenic, antimony, bismuth. That is the 15th group. And we are adding arsenic in place of silicon. So arsenic has 5 valence electrons. It is like 285. So the last shell will be having 5 electrons. So there is an excess of 1 electron. So it will be like somewhere, it will be somewhere over here. Okay. So see, 1 electron, extra electron is here. When we added 1 arsenic, when we replace 1 silicon with an arsenic, and if we are replacing more silicons with more arsenic, there will be a lot of extra electrons gets generated, lot of extra electrons keeps generated. And so this is an n-type impurity, and the conductivity is mainly due to the electrons, movement of electrons. So in general, we can say in a superconductor, the conductivity is mainly due to the electrons and holes. So this is an n-type semiconductor, and this n-type semiconductor is having an excess of electron. But see, holes are also there, but holes are very less in number compared to the extra electrons in this. So the majority carriers in an n-type will be electrons, and the minority carriers will be holes. Okay, so that is it. So in an n-type, we are applying voltage. So see, in this n-type, we are applying a voltage. What happens? The electrons will get attracted to the positive terminal, and the holes will be getting attracted to the negative terminal, because n-type electrons are the majority carriers. So since holes are less, the majority current will be due to the electrons. And if we take the case of p-type, in p-type, what happens? The majority are holes. See, holes, and electrons are in minority, only two. See, so we apply the voltage. So when voltage is applied, since hole is like, we consider it like a positive thing, so it will get attracted to the negative terminal, and the electrons here, electrons which are very small in number, it will get attracted to the positive terminal. Since the electrons are less, the majority current will be due to the flow of these holes. So this is how it happens, and this is the basic of semiconductors, like intrinsic and extrinsic semiconductor. Extrinsic semiconductor can be classified into p-type and n-type, and you understood like how p-type and n-type semiconductors are now formed. Okay, let's continue on the next session. Thank you.